Okay, now we're ready to go on to 13.2. Solving by completing the square. Like I mentioned last time, you will use completing the square a lot in Math 3 and Honors Math 3 next year as you do more complicated graphs. So all this is very important. We are going to solve, so we are going to do what we did in the first lesson by completing the square and find that C value. But instead of writing the equation out, we're going to actually solve. And so you guys understand solving means x equals find x. If I ask you to solve something, you're going to get an x answer. So using this method to solve quadratic equations when the equation is not easy factorable. You're going to learn later on in this chapter there are different ways to solve quadratics, anything with x squared. Factoring, square rooting, okay? This is completing the square. There's another method called the quadratic formula that we'll get to. This is best if the b term is even. So that means like when you have this number is an even number. You don't want to complete the square if it's odd, because then you get a fraction. It's not worth it. So here's what we're going to be doing. Move the c to the other side. We did that on 13.1. Find the value that completes the square. That's the c value. We did that on 13.1. Add the square to both sides. We did that on 13.1. Write in factored form. We did that. This is the new thing. You don't move the c back over. That says back. Okay? So that's the big thing, because we did all this, but before we moved the c back over and we would write it as y equals. Now we're not. We're going to square root both sides and solve for x. So it's going to look like this. I would rather do this, where I'm actually finding an answer. This, if it was a factorable question, you would factor. Nothing multiplies to be 4 and adds to be negative 12. Can't do it, so I'm going to complete the square. First part, move the c over. And you'll notice these are all equal to 0, because when we solve, we make it equal to 0. We're going to put 12x. Remember, we put a square. You can put a parentheses if you want. I just like a square. And we're going to complete the square. So you take half that number and square it. Half that number is negative 6. Add factor into x minus 6, x minus 6. Negative 4 plus 36 is 32. And then we're going to square root it. I actually started you guys out with kind of a hard one, but then you can kind of see that sometimes it's easier. This is about where the hardest it's going to get. At this point, we're not moving the 32 back over. We are going to solve it. So we are going to square root both sides. When you square root something, you get that by itself. When you square root 32, you guys might know that's 16 times 2, 4 times 4. We want to write it as a simplified square root. We also want to remember that every time you take a square root, there are two answers, plus or minus. So I'm going to write this as plus or minus 4 radical 2. Now I have to solve for x. To get x by itself, I have to add 6. Okay, I'm going to be picky about this. Your answer should always have the real number plus or minus the radical. The radical should always be at the end. You cannot add those because they're not like terms. So it's always a real number plus or minus radical, if it still is a radical. Okay, so let's try this on the next one. Same thing. Subtract 23. X squared minus 12x. I'm going to put the square. I don't have to take out a GCF. You notice, like those last ones on 13.1. Half of 12 is 6. 6 squared is 36. Same type of question. Factored on the left-hand side exactly the same. This side over here is 13. Take the square root. Okay, 13 is a prime number. Can't break it down. But it's still plus or minus anytime you take the square root. Add 6. Very similar question. The only difference is we couldn't break down the square root and simplify it. They're very simple. Similar. Okay, so the next question. What you should notice is these aren't equal to 0. The c is already moved over. Don't move it back. Silliness. Leave it there and just complete the square. We didn't have to move the 24, so it still stays positive. Half that number is negative 8. Negative 8 squared is 64. X minus 8 squared. That's 88. Take the square root of both sides, move this up a little bit. Okay, so that's x minus 8. Now I'm going to break down 88. That's 8 times 11, 2 times 4, 2 times 2. So this would be plus or minus 2 radical 22. Don't forget that 2 there. And then add 8. So your answer would be x equals 8 plus or minus 2 radical 22. If you don't put the radical at the end, I will tell you to fix it. Okay, you might want to try this one on your own. It's up to you, but this one's a little bit different. I don't want to do too many problems. I had to give you, like, these two are pretty much the same, but this one's a little bit different. Okay, so 75 is already over there. Oops, that's a 20, sorry. Square. Make this 100, right? Half of 20 is 10. 10 squared is 100. This is n minus 10. And it doesn't matter if it's n or x. I'd rather have it all be x, but no, whatever. Okay, now, take the square root. Why is this one different? Because you can actually take the square root of 25. So n minus 10, n minus 10 equals plus or minus 5. Okay, this is the mistake I'll see. People will write the answer as 10 plus or minus 5. Well, this you actually can figure out. It's going to be 10 plus 5 and 10 minus 5. The answer is 15 and 5. Two answers. Everything has two answers. If it is a whole number, we actually can't calculate the whole number. Okay, next page. Move this back down. Okay, so we're going to keep doing this a little bit more, and then we're going to relate to graphing. You guys mostly be happy because there's not that much graphing on this section, but we are going to relate this to graphing a little bit. So we're going to do the same thing. 63 is already over. Don't have to worry about it. What goes in the square? All right, 81. This is y minus 9 squared. So that y is ugly. Equals 144. This is another one of those where I thought I'd give you another one where it actually calculates out. That equals plus or minus 12. Then you're going to add 9. So you get two answers. Y equals 9 plus 12, which is 21, and y equals 9 minus 12, which equals negative 3, which means that this was factorable to begin with. Okay, let's try this one. Another one that comes out to be a perfect square. Half of 10, whoops, let me move that, let me put a square there. Half of 10 is 5, 5 squared is 25. B plus 5 squared equals 100. Again, take the square root. B plus 5 equals plus or minus 10. Subtract 5. Okay, so remember this would be B equals negative 5 plus or minus 10. So you have B equals negative 5 plus 10 and B equals negative 5 minus 10. So your two answers are 5 and negative 15. Okay, last one, just to do one more so you guys get an idea. This one, kind of weird. It's not equal to 0 and the c is not moved over. So we still have to move the c over. Because you want it to be just that before you complete the square. Negative 26 plus 8 would be negative 18. And then we're going to put a square. Half of 10 is negative 5. Negative 5 squared is 25. Remember, these will always be positive. X minus 5 squared. Negative 18 plus 25 is 7. Take the square root. X minus 5 equals plus or minus radical 7. Add 5. I'm going to put the answer over here. So x equals 5 plus or minus radical 7. So if we kind of go back through, we did some where you had to simplify the radical, some where you didn't simplify the radical, and then some that actually end up to be whole numbers. Okay, so how is this related to what you guys learned how to graph? Okay, so let's go through and look at some graphs. So there's two graphs here. We need to write in vertex form y, easiest to graph. find the vertex. It's the most important part. If you notice on word problems, it's the max, so it always is important. Find the x and y intercepts, so it's easiest to graph, and then sketch the graph. Now this is one where it's not factorable. Nothing multiplies to be 8, negative 8. That's going to give you positive 2. Oh wait, is it factorable? Maybe, but we'll just do it by pretend it isn't factorable. Okay, the first thing I'm going to do is I'm going to fill out the y-intercept. I know it's 0, negative 8. Because if I put 0 in here, I get negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put that dot on. Okay, I need to have this in vertex form, so I'm going to complete the square. Okay, so now we're back to 13.1. We're moving the 8 over, and we complete the square. So we're actually going to do what we did in 13.1 and what we just did. So half of 2 is 1. It's going to be 1. X plus 1 squared equals 9. And I'm going to write in vertex form. So x plus 1 squared minus 9. Where did I get that? I moved the 9 over. That tells me the vertex is negative 1, negative 9. Kind of goes off the graph, but right there. Okay, I know this graph opens up. I know it's a normal shape graph. I need to also find the x-intercepts. So now what I'm going to do is leave this and solve it. So if I find out what x equals, that gives me the x-intercepts. X plus 1 equals plus or minus 3. Subtract 1, so I get x equals negative 1 plus 3, which is 2, so you have an x-intercept at 2, 0. I get x equals negative 3 minus 1, which is negative 4, which gives you negative 4, 0. So 2, 0, 1, 2, 3, 4, 0. Everything should be very symmetrical. If you know that dot's here, you also know that dot is there. And if you wanted to check, you go 1. The next one is 1, 2, 3. The next one will be 1, 2, 3, 4, 5. You can do the 1 through 5 method. So you used everything you know here. You used finding a vertex form to help you find that point. Find the x and y intercepts by using what we did up there. Okay, so one more. I didn't leave myself very much room. First of all, I know the y-intercept is 0, negative 5. If I put 0 and I get negative 5, 1, 2, 3, 4, 5. I'm going to put this in vertex form, which I have no room, so let me get a different color. I'm going to squeeze it in here, sorry. But x squared plus 4x plus square equals 5 plus square. Because I move the 5 over, this is 4, this is 4. So x plus 2 squared equals 9. That means that vertex form is x plus 2 squared minus 9, because I'd move the 9 back over. That means your vertex is negative 2, negative 9. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I really should make the graph so there. Can go to negative 9 because I use that number so much. I also know if that's 2 away, I can go 2 away and get that point if it helps. So everything's symmetrical. And I need to know the x-intercepts. I'm just going to square root. So x plus 2 equals plus or minus 3. Subtract 2. You get x equals negative 2 plus 3, which is 1, 0. And then you get negative 2 minus 3, which is negative 5, 0. Sorry that it keeps going off the graph. 1, 0, 1, 2, 3, 4, 5. Everything should be symmetrical. Looks like that. If you want to do the 1, 3, 5 method, this would be 1 apart, this would be 3, and this would be 5. So now you can graph. Okay, good luck with the next worksheet, and then you got a whole week to do it, and I will see you guys next week. I will post a riddle. I think I have one I want to use. I will probably post it either tomorrow or Wednesday. Good luck. Bye.